Okay. Good. Next question, please. Anything else?
Can we do number 8?
Yes, of course. Number 8. Yes.
Yeah, the function.
Yes. Which one or both? It doesn't matter to me. You want to do the rational or you doing the polynomial? We can do both. Let's do both. Okay, so we have f of x equals 2, x minus 2 right away, x minus 1, x minus 2. So when I see a rational function, this is my first thought immediately, to completely factor it and see what's happening and state a domain. And obviously the domain is clearly x not equal which numbers?
2.
Good. So now I can simplify this. I cannot simplify it before I state a domain. This is extremely important. And now the simplified form of this fraction or function is this. 2 divided by x minus 1. Still, the original function is still undefined at 1 and 2. Okay, very good. So I start at my table. Okay, in which I have to put 1 and 2, and of course 0. Negative infinity, 0, 1, 2, infinity. Undefined at 1 and 2, you already told me that. So because the factor of x minus 2 disappeared, what will x equals 2 represent? If it disappeared, no. If it disappeared, what does it represent when it disappears? The function is still undefined at 2. But it can no longer be a vertical asymptote because that factor disappeared. But it's still undefined there. What can it be then? It's not a vertical asymptote. In other words, the sides don't go to infinities, but it's still undefined there. So then what happens there? What is the other option? Exactly. So x equals 2 is a hole in the graph. But what about x equals 1? Since it did not disappear. Exactly. That will definitely be a vertical asymptote. No question. Good. What type of rational function is it? Is it type 1, type 2, or type 3? Let me refresh your memory on those 3 types. Type 1, same degree over same degree, horizontal asymptote, leading coefficient over the leading coefficient. Type 2, higher degree in the denominator, horizontal asymptote 0. Type 3, no horizontal asymptote, higher degree at the top by 1 unit higher than the bottom, slant. So is it type 1, is it type 2, or type 3? Say it again. Is it same degree over same degree? If it's same degree over same degree, it's type 1. degree of the top has no x, so it's degree 0. Degree of the bottom has x to the first power, so it's degree 1. So degree 0 over degree 1 cannot be type 1. Degree 0 over degree 1 is type 2, where the degree of the denominator is bigger than the degree of the numerator. So the horizontal asymptote is for type 2. Perfect. So y equals 0, horizontal asymptote. When I plug in 0 for x, so I need a number here, what do I get?
-2.
Very good. When I plug in 2 in this form, what do I get for the whole, left and right? When I plug in 2, what do I get?
2.
How much is 2 minus 1?
1.
How much is 2 over 1?
2.
Very good. Awesome. And now on this side, I'm going to plug in 0.9 and 1.1 to determine the sign of the asymptote, of the end behavior, left and right of the asymptote. So 0.9, what sign do I get?
Negative.
Perfect. So this will be negative infinity. And with 1.1, what do I get? Very good. Awesome. That's all we need. When we graph a function with asymptotes, what do we have to graph first? Very good. So we have a horizontal asymptote, so there is really no need to reinforce, but okay, I'm going to do it anyway. Because we have the x-axis. 0, -2, 0 for x, -2 for y. We have a vertical asymptote, which is 1, x equals 1. And we have an ordered pair that is an open point at 2, 2. So, ready? From approaching 0, crossing the y-axis at 0, -2, and going to negative infinity. From approaching 0, crossing, and going to negative infinity. On the other side, from positive infinity, going through this hole, and then approaching 0. And this is the graph of f of x to x minus 4 over x squared minus 3x plus 2. If you want to check with the graphing calculator, you should always do it, just in case. Next question, please. Anything? You have till Sunday to finish the EMI Math Lab, please. It's part of your grade. I don't want to put zeros. Please. Unless the system already puts them in automatically. Next question, please. Which one?
I would actually just ask for another example of completing a square.
Yes. Yes. Complete the square is in chapter, I have the book right here. So let's choose from there. Complete the square is the beginning. Let me see. Other types of equations, quadratic 1.5. 5, complete the square, complete the square. Yes. Let's say x squared minus 3x minus 5 equals 0. Oh, we have also the polynomial function, I think we wanted to. So the equation we're asked to solve using complete the square. I have to apply the same steps. What are those steps? Middle coefficient, which is?
3x.
No. The middle coefficient has nothing to do with the variable. The middle coefficient is the number in front of x. Has nothing to do with the variable. So the middle coefficient is -3. Then I divide it by 2, and then I square to get 9/4. So I have to add 9/4 to both sides. So let's rewrite the equation for a moment before we proceed. So now the new equation is x squared minus 3x plus 9/4 equals 5 plus 9/4. So the point I'm making here is it's up to you. You can make moving 5 to the other side into a new step. There is no point. You can do it later. So you focus on -3. -3 divided by 2 is -3/2, and you square to get 9/4. And when you put 9/4 to the other side, you can also move -5, and it becomes +5. Don't make a -5 a step, because this is not important. What is important is to determine what you need to add to both sides. So then all this now is changed into this. The least common denominator is 4, so 29. But now the question is, what do I have in parentheses? So that when I expand this, I get 1, 2, 3 terms. The exact 3 terms I see there. It has to be x. It has to have minus. What I squared to get this. What did I square to get 9/4? That's it. So let's check if you have any doubts. First term squared is this. Minus. Minus 2 times the first times the second is guaranteed to be -3x. Plus the second term squared is guaranteed to be 9/4. So now, of course, if you remember, we said, okay, completing the square will not really solve the equation. It will not. If I don't remember that I have to use taking square roots, I have not solved the equation. So this is the second method that I need to apply. And I get x minus 3/2 equals plus or minus the square root of 29/2. And I move 3/2. And I have to be very careful. It's positive 3/2. Plus or minus square root of 29/2. What I was going to say is that I have to move 3/2 in front of plus or minus. Not between plus or minus and this. And that's very important to remember. Next question. Anything else that you wanted to go back to? Oh, yeah, let's do the polynomial. Sorry. Okay, so we have g of x, -x, x minus 3 squared, and x plus 2 to the third. What is the domain of a polynomial function? I cannot stress enough, between now and Saturday, please redo each test with solutions multiple times and come back if you can, if you're available on Saturday for questions. And say, I need another problem like this or another problem like that. But if you don't review the tests, all 3 tests, at least twice, then you will not know what to ask. And we will not have time in an hour and a half to review everything. Okay? So in 20 minutes, I will post the test 3 solutions. So you can go back and redo. Okay, domain of a polynomial function. Right. Like exponential functions, polynomial functions are very friendly. They are defined everywhere. We have no restrictions whatsoever. Okay. What will be the x-intercepts? And what is the degree, first of all? Three here, 2 here, and 1 here. 6. Very good. So I need 6 solutions. So when g of x is 0, please give me 6 solutions. Yes? In any order you want. It doesn't matter. 0 once, multiplicity 1. X equals 3, multiplicity 2. And x equals negative 2, multiplicity 3. 3 plus 2 plus 1, 6. So I have negative 2, 0, and 3. 0, 0, 0. What does multiplicity 1 mean? So I can put a note up there. Multiplicity 1 means a cross. Multiplicity 2 means a turn. Very good. Here. And multiplicity 3 means but slow. Very good. And behavior. It's degree 6. We compare it to which very simple function, polynomial function. If it's degree 6. We compare it to which one? The 2 simple ones are linear, quadratic. Which one do we compare it with? With linear or quadratic? If it's degree 6. I cannot compare degree 6 with a linear degree, right? It has to be with quadratic. So it has to look like this, either coming from positive infinity going back to positive infinity, or like this, going from negative to negative. What is the leading coefficient? Negative 1. Is it this, like x squared, or is it this like negative x squared? Yes. So then the end behavior will be negative infinity to negative infinity. Very good. If the degree were 5, what would you have compared it to? To x squared or to x? To x. And it would have been this situation or this situation. Okay, perfect. Okay, so let's start by plotting the x-intercepts. So we have 1 at negative 2, 1 at 0, and 1 at 3. It's coming from negative infinity, and it's crossing a negative 2, but slowly. Okay, fine. Cross slow. It has to come back. Oh, I forgot to ask you what is the maximum number of terms? Turns. Max number of turns possible is? Exactly. Not more than 5. Very good. So it crosses at negative 2, 0 slowly. It has to come to a maximum because it comes back and it crosses again, this time straight. It has to come to a turn because it has to come back and turn again at 3 and then go to negative infinity. So it has a local max here and a local min here. And of course also a local max here, which is at 3, 0. But I don't know that max and that min. So I can go back, put it in y equals. Okay, I got it. In y equals, we had negative x in parentheses. No, I didn't mean that. In y equals negative x. And in parentheses, we have x minus 3 squared And again in parentheses x plus 2 cubed. Standard viewing window, okay, standard for now. I'm going to say show me. It will cross at -2. Will go to a maximum. It will cross straight at 0, 0. It will come to a minimum, and you will have a turn here. So obviously, I have a lot of adjusting to make. So I'm going to say -5 to +5, and much lower and much higher on the y-axis. Okay, so -5 to 5 with a scale of 1 is fine. Y minimum, I don't know. I'm going to say negative, I don't know, it looks like, I'm just guessing, -200 to +200 with a scale of 50. We'll see. We'll see how far I am from the truth. I could be very far still. Okay. Not bad. So it has, see the difference between this cross, which is a straight, fast cross, and this one? Because there are 3 solutions here. Same number, but 3 solutions right there. So it crosses slowly at -2, 0. It's coming to a maximum, crossing straight at 0, 0, coming to a minimum, and turning at 3, 0, as we expected. So I'm going to try to find this between -2 and 0, and I'm going to try to find this between 0 and 3 for x. So second and calc, I want a maximum, which is 4, between -2 and 0. -2, 0, and enter. And I'm getting this, which is -0.6, and it's 21, roughly. So this point, -0.62, 21.4. Now I want to determine the minimum, which is between 0 and 3. Go back to second and calc. This time I want a minimum, which is 3. And I want it between 0 and 3. And enter again. And it will give us 1.62, 1.62, -146.4. And I put those either in the table or on the graph. And this is the function f of x -x, x minus 3 squared, x plus 2 cubed. Next question, please. We have about 5 minutes left, so let's use them productively. Yes, Marcus, go.
We already went through it, but we would go through another example of a difference quotient.
Yes, of course, very good point. Yes, let's make up a function and find a difference quotient, which is f of x plus h minus f of x divided by h. Yes, let's make up a function. Yes? Yes, any function, please.
3x squared minus 12x plus 36.
Perfect. So this is a quadratic function. We are asked to find and simplify the difference quotient. Perfect example. Now the question is, what do I have and what do I have to work on? I do have f of x, so that piece is given to us. What else? Yes, there is nothing I can do to h. H is just a letter, right? A minor change. And this I don't have. I have to work on it first. So then f of x plus h equals. How do I determine this? How do I determine f of x plus h? It's the same thing as determining f of 5. It's the same thing.
After x, we put x plus h. Replace.
Yes, so I'm ready.
3
Yes?
x plus h squared
Yes?
net minus 12 x plus h plus 36.
Yes. So f of x plus h is the same with f of 3 or f of 10 or f of 100. It's just that I'm replacing now x by x plus h instead of 3, 100, and so on and so forth. I have to expand this, right? So what does that equal to?
X squared
Very good.
plus 3xh
It's 2xh, yes, plus h squared, minus 12x minus 12h plus 36. And then now I distribute 3x squared plus 6xh plus 3h squared minus 12x minus 12h and plus 36. So this was the biggest part. Now putting it all together is not going to be difficult, but there are two things that have to happen for any difference quotient for any function. What has to happen? We get rid of all the terms without h from the top, and then eventually, right before the final step, the h in the denominator must go away. So that's all we have to do right now. So the difference quotient will be 3x squared plus 6xh plus 3h squared minus 12x minus 12h plus 36, and then minus 3x squared plus 12x and minus 36 divided by h. So I had to distribute -1 in the function because I have to subtract the function. So assuming that there was no mistake, all terms without h must go away, and they do. The 3 remaining terms must have h in common because I have to pull it out because eventually I will simplify it with the h in the denominator. So what is left in parentheses? I need 3 terms. And this is 6x plus 3h minus 12. And that happens to be the final answer.